Good afternoon, everybody. It's good to be back here in Kyiv. As the title suggests, this talk is about an update on what's coming in Java EE 8. But the goal of this talk is actually a little broader. It's just as much about informing and encouraging about to get involved in this process and defining what Java EE is really about. I'll go through possible features. Some of them are longer in the process than others. And I hope you find some of them intriguing and interesting to work with, so you'll join the JCP or adopt the JSR process. And I'll also go through how to do that. Or even better, if you come up with new ideas or missing features that you mean should be a part of the specification. So, who am I and why am I here? I have been coding Java since '95. I've been doing it professionally since '98. I work for Cybercom. We're a consulting company based in Sweden, where I do consulting and speaking at conferences like this one. And as you see, these photos are pretty old. Not that one, that's last week at Java 1. But if you take any photos today, just tweet them to me, and I'll update my slides with them afterwards. And the other reason why I'm here is that I'm a member of the JCP. I'm in 3 expert groups, the one for JMS 2.1, the one for MVC, and Java Security API. We'll get into those later. So the agenda for today is how we got where we are, where we're going, and how you can be involved in going further. So let's look at how Java EE has evolved up until today. And historical context is kind of important to understand what and why we're doing what we're doing. So let's start with the J2EE period. And when everybody hears J2EE, it's kind of scary. That was old, it was complex, it was hard, it wasn't very well received by the community. And thus framework like Spring and Hibernate and alike came around and kind of forced changes into J2EE. Then Java EE 5 came along. And the programming model and changes from the community got included and got its own set of key innovations. And the key changes in Java EE 5 were the POJO programming model. You can use annotations. You didn't need all this XML anymore. You got intelligent defaults and kind of an aim for a zero configuration system. And as a result of the changes that came in Java EE 5, Java EE is actually one of the easiest to use platforms available today. And in Java EE 6, this work was taken even further. The key change in Java EE 6 was to introduce first-class generic dependency injection as a built-in part of the platform, and this is called CDI, or Contexts and Dependency Injection. And the industry reception of Java EE 6 has been really great. And there's a growing adoption of Java EE. And Java EE 6 also introduced something called a web profile. That means you can run a lighter version of the application container. So you didn't need the full version. Because most applications out there are, anyway, web-based applications. And then Java EE 7 came, and that was in 2013. And Java EE 7 built upon Java EE 6, and it had 3 very important themes. And that was to enable the platform for HTML5. And it was to increase the developer productivity of using the platform. And it was also to meet the enterprise demands. So what was done in HTML5 era was to includes support for WebSockets and CSS3 and etc. And also make these available to support it from server side. And developer productivity was increased by doing it even simpler. I mean, just think about how you define an EJB today. It's one single annotation, as opposed to in the first version of the specification, where you had to implement 3 different classes and a couple of XML files and deploy it separately, right? So it's really much easier from a developer perspective to get productive. And meeting the enterprise demands was to, among other things, to update the JMS specification. So it got much easier to do JMS. So Java EE 7 had some new specifications, lots of updated APIs. And some of them were even lifted to major releases, such as JAX-RS and JMS. And the new stuff that were added were concurrency utilities, support for batch applications, and Java API for JSON. And you also got the WebSocket support. And the whole ecosystem was updated. And it's always important to remember that Java EE forms the stable core of a vibrant ecosystem. And things like Archillion, Delta Spice, Forge, Prime Faces, and so on continually move the ecosystem forward by building up on this standard. And the industry is really adopting Java EE 7. There are lots of platforms implementing it out there. GlassFish 4, which is a reference implementation, was first. Then you got Wildfly 8, 9, and 10. And etc. WebSphere with this Liberty profile supports Java EE 7. And recently, WebLogic launched a Java EE 7 compatible version. And it uses actually many of the open source components from GlassFish 4. You also have the commercial version from JBoss EAP is building upon Wildfly and will soon be Java EE 7 compatible. And you have Tommy, which is the Tomcat-based open source Java EE application server. They are currently supporting Java EE 6, but will be moving on to Java EE 7 soon. And all of them will catch up eventually. So as I said, the reference implementation for Java EE is GlassFish. So both GlassFish 4 and WebLogic 12 were released in around Java 1 2014, that was last year. And GlassFish 4.1 fixed a large number of bugs. It supports CDI 1.2, WebSocket 1.1, and it also supports Java SE 8. So, the newest version of GlassFish, version 4.1, also implements the reference implementation of MVC, which is called OSARC. So if you download the latest nightly or version 4.1.1 of GlassFish, you can actually play around with Java EE 8 features already. So Java EE 7 significantly increased the community involvement in the process compared to previous releases. And for Java EE 8, we want even more community support. So there were a community survey done. And this is a result of this survey. And the survey was built up to asking developers for feedback. What do you want into the next version of the platform? And what our features are important? And you can also provide open feedback for anything you thought of in that part. And the service run for 3 months and we received about 4,500 inputs. And the data is represented from people all around the world and all kinds of organizations. And the results of the service is available for anyone to see. And kind of shows how the community prioritized the features. So based on the survey, these are the proposed themes for Java EE 8. There will be web standards and HTML5 alignment. We'll support the HTTP2 protocol. There will be done changes in the CDI to make it broader across the platform. And cloud support. Amongst other, the Java EE Security API will make it easier for applications to manage its own security, so it's better cloud enabled. And as I said, the CDI alignment will continue. EJBs will be updated. We'll implement caching in JCache. And also make use of the Java SE 8 features, such as Lambda expressions. So we can maximize the use of these in the Java EE world as well. So the current status of Java EE 8 is that it started, it's really going on, and many of the JSRs were launched last year, so they've been worked on for a year. Nothing is final yet, so it's still a lot of time to contribute. And a couple of the JSRs, such as security, Java EE management, and JSON parsing, were launched more recently and are a little bit behind in the process, but it's still going on and needs a lot of feedback. And there are also a couple of minor releases for WebSockets, concurrency, and JPA that hasn't started yet, but are still to come. And again, it's plenty of opportunities to participate. And every expert group wants involvement from the community, because we want to do things right this time, right? So let's look at a couple of these JSRs. And start off with the Servlet 4 specification. That is actually one of the most important changes in Java EE 8. And the principal goal of Servlet 4 is to bring HTTP2 support to Java EE developers. And HTTP2 is an update of the HTTP protocol, which was originally designed with a very simple web in mind. Like a request to a web server was expected to produce just one artifact, an HTML page with some links in it. But the web today is more complex than this. And one single page can have possibly lots of dependencies to many resources, such as images, style sheets, scripts, videos, and so on. And as a result of that, we currently lose a lot of performance for each dependent resource that is retrieved through a separate HTTP request. Like you need to do one request per resource, actually. And HTTP2 is aimed to boost this performance by fixing this mismatch. And that means it allows to transfer a number of resources from the server in a given request over a single TCP connection. So you can actually multiplex this connection into streams. And these streams can be assigned priorities, such that the client browser can retrieve what's absolutely needed to render the page, and then do the other things in the background. So the protocol will actually support much of the things that we're doing manually today. And the goal of this specification is also to build this support into the APIs, so you as a developer actually won't notice it. It will just be there. Java EE 7 includes a low-level JSON parsing API that is kind of like JAX-P in the XML world. And one of the features the community asked for was a higher level API for binding, more like JAX-B for XML. And this API should be very transparent and mostly work with POJOs as it is. So this specification will create a small number of annotations so we can override default mappings, such as renaming fields and such. And it will build on existing non-standard JSON binding libraries such as Moxie, Jackson, JSON, Janson, and etc. And it will allow for switching these providers at runtime. So for the most part, developers shouldn't be able to need this, to know the specifics of this API. It just be handled by the rest of the platform. And JSON binding has actually been supported in GlassFish for a long time, but using the non-standard Moxie. So let's look at some code. This is very illustrative code. And by the way, all the code I'm showing today is very illustrative because it's work in progress and we don't know how it will look eventually. But if you have any input, the expert groups will be very happy to hear it. So the POJO here is a very simple JPA entity that is initiated just using the new operator and then manipulated on it, like you set the name for Duke and etc. And JSON-B will actually just use simple reflection and default mappings to produce a corresponding JSON output. So you don't have to do anything manually to create the JSON. JSON-P will also be updated in Java 8. And like many other web standards, JSON is also moving forward steadily. And one of the standards are JSON pointers and JSON patch. And JSON-P will aim to support both of these new web standards. And also, JSON-P aims to better align with Java SE8, especially to use Java 8 streams. Another example, a JSON pointer is very simple to XPath in XML. It allows to search and reference parts of a JSON document using URL-like paths. Like this code example shows that the pointer created by JSON create pointer points to the first element, phones, and mobile number. And you can get this value. And JSON patch is very similar to the HTTP patch. It actually allows to issue commands to modify a JSON document. And as this code shows, it shows an operator field, which is called replace, that takes the first mobile element and replaces the value in it. And the operator removes the first element. And this is how this is illustrated. You see the op replace takes out the mobile number and replaces it with another value. And similarly, the op remove takes away the whole element. To some degree, it's already possible to use Java SE8 streams with JSON-P, as long as you convert the JSON objects to a collection. Like in this example, you collect the collectors with a toList. What JSON-P aims to do is to add specialized collectors so you can actually have a JSON array that you can get from the stream if you. JavaE has really strong support for REST using JXRS. And this is present in Java EE7. In EE7, it was also added support for WebSockets. And when REST is intended for traditional HTTP-based stateless request response, the WebSocket is almost the opposite. It's still HTTP, but it's stateful and bidirectional. And the connection is kept open for as long as necessary. And server-side event, or SSE, is something in between, like regular REST, HTTP, and WebSockets. So we can actually open a connection to the client and send some events over a period of time. It's not like the WebSockets where we have the connection open all the time. And this server-side event is really good when you say that if you update an element, I can show some code. For example, here you can have a post that updates the quote, and you can have the same resource actually doing updates of the client by using the new API for server-side event. And we're adding a new MIME type called text event stream, and a new response type called event output. So we don't return a HTTP response as we do in a JXRS. And then you can send a response over a stream to the client. And the majority of server-side event clients will probably be written in JavaScript, but there is also a client API available in Java, just similarly as the JXRS client. And this is illustrated in this code. So while processing server-side events, clients create an event source and attach it to a web target. And this event source triggers an event listener as it receives event from the server when the connection is opened. And in the example, each inbound event has a stock quote. And this is very similar to how the W3C standard is for JavaScript. So let's move over to MVC. MVC is a standard action-based web framework for Java EE. And you may ask, doesn't Java EE already have a MVC framework in JSF? And yes, it does. But JSF is what we call a component-based MVC framework, where it's the framework that is the controller. So the controller in JSF is actually the faces servlet. Whereas in MVC, it's up to the developer to implement the controller. And this is what it's called action-based MVC. And it will coexist with JSF, so it's no plans of phasing out JSF. They will both exist, and they're both wanted. And actually, MVC was one of the most wanted features of Java EE. And the majority of the work is done in the controller. And I'll show you some code afterwards. One of the first decisions we did in this expert group was to decide that we are going to build MVC on top of JXRS. And that means we already have much of this functionality we need in place. Like the code example you see here is mostly just as you would write a JXRS resource. The only thing is the new @controller annotation. And in this example, I've put it on the method. That means this is a controller method. And the rest of this class could just as well be a JXRS resource. It's also possible to put the controller on the class level, and then all methods would be controllers. The rest of the parameters are from JXRS. And in this case, I just return a hello.jsp page. And the implementation will know where to find that page and render the HTML output. There are also other ways of doing this by either using a @view annotation or returning a response with a view object in it. Another of the most popular requests for Java EE 8 was to simplify Java EE security. And we all know how important security is, and we all know how bad it has been in Java EE, and hard to implement and not very flexible. So the goal of this specification is to streamline the new Java EE application security, improve the portability, and especially with the cloud in mind. And to do this, we will try to provide a simple application-defined security providers approach to allow simple pluggability and mappings for custom security providers within the application. And we also want to enable the existing EJB security annotations, such as @roles_allowed, for all managed beans. So you should be able to use them via CDI, and you also should have expression language enabled security annotations and CDI interceptors. So you actually use some of the good stuff that came in Java EE 7 that enable us to build a proper security API. And in the security specification group, we have identified these epics and this is how they relate. And so far, what we've been working on is to standardize how we talk about these things. It's actually defined a vocabulary for security in the Java EE Enterprise. And one of the items we've come up with is the identity store. That is where we store the user identities. And we also started looking at authentication mechanisms. And as you see, in the middle we have security context. And if you've done some development with Servlet technology, and some with JXRS, and some with EJB, and maybe some simple CDI, you know that to get hold of a user principle is kind of different in all the ways. There are different method names. You get it from different contexts. In CDI, you don't have it at all. So introduce a generic security context that is available across the platform is also one of the goals. And also password aliasing, authorization interceptors, and simple role and permission assignments. And you should be able to do it from the application. And here's an example. This one shows an embedded identity store. So if you're in, this is absolutely nothing you would do for production, but for testing on your local environment, you can actually have an embedded identity store in your application. And when you deploy it to another environment, you will have something that isn't embedded in the code, but maybe in a database or whatever. And it also has an example here with the database identity store definition. And we actually have lots of pretty much working examples on our Git repositories on GitHub. So everything is available, and you can go in there and play around with it. And we also want to add a simple expression language. So you can actually go, the names and annotations are probably not what they're going to be, but how you're going to write these expression language security annotations, like this one. If you're a manager and it's within office hours, then you can transfer the funds. Otherwise, you won't be enabled to do it. So it's going to be easier and more clearer for the developer to know when and how is this method actually going to be run. Those of you who have worked with JMS before JMS 2 probably know how cumbersome it was. And JMS 2 was a really vast improvement in how messaging was done in Java EE. And also for Java SE, actually. And what we're aiming for with JMS 2.1 is actually to continue that work with some things that didn't make it to JMS 2.0. And one thing is to have a declarative message listener. And we want to simplify how message-driven beans are written. And we also want to make regular CDI managed beans available to be listeners. And also to explore the provider portability, along with a couple of bug fixes to JMS 2.0. So here's an example of declarative message listener. You see here that we actually, the message-driven bean doesn't implement the interface message-driven bean. It has an annotation for JMS message-driven bean. And this is what we call flexible message-driven beans. So it's going to be easier, more Pojo-style way of defining a message-driven bean. And we're aiming to have annotations for saying, in this case, that duplicates are okay. And selectors for which types of JMS. If it's a pink car, this one will select it. And also, we're adding an on-message annotation so that the method doesn't need to be called on-message anymore. And you can also have more listener methods in the same message-driven bean. After Java EE6, there's been two releases of or updates of CDI. That's CDI 1.1 and 1.2. And in Java EE8, we want to include a major CDI 2 version. And the goals for CDI 2 is pretty ambitious. So far, CDI has been very Java EE-centric, even though the major CDI implementations also support Java SE, but it's not very standard. And the goal is that CDI 2 will support a subset of features in Java SE as well as in Java EE. And also some of the newer APIs, such as JAX-RS and WebSockets, isn't very well supported by CDI. And so far, CDI actually doesn't support any XML configuration. And you may ask, why would we want XML configuration back? But in some cases, it may make sense. And CDI is today has a very good support for events, but it doesn't have any asynchronous support anymore. So we want to add asynchronous CDI events, and also possible to have the EJB annotations like at startup and at asynchronous and at schedule also available for CDI managed beans, so you don't have to have an EJB to have it scheduled. So this code example demonstrates how CDI events could be made asynchronous. There are two possibilities actually. It's adding an asynchronous event firing methods or make the observers asynchronous. And CDI2 can make both or one of these. They haven't decided yet. And here's an example where an EJB at schedule annotation is made available to a CDI managed bean. In J2EE, there were a API that aimed towards managing and monitoring applications in a standard fashion. But this is based on EJB2 remoting and Corba. And one of the more popular items in Java EE8 survey was a desire to have such a standard API that utilizes REST. So you can actually monitor your applications on a REST-based API or server-side events. So you will be able to manage not only server-side life cycles such as stop-start and monitoring, but also monitoring the resource and state and deployments and undeployments and everything in a Java EE environment. And Java SE8 brings a very useful set of changes that has been extremely well received by the community. And most of it can be used with Java EE. Servers such as GlassFish, Wildfly, WebSphere, and WebLogic, they all support JDK8. But some of the APIs could adopt these features better, such as Daytime API, completely the future, and Lambda expressions built into the API. So there's an aim to align Java EE better with Java SE. And there are also other things that I haven't had time to go through today, such as reactive programming with JXRS client API, and more hypermedia support in JXRS, and etc. And we also want to start removing the EJP2 interfaces and the Corba interoperability. This diagram shows a rough timeline for Java EE8 and GlassFish 5. GlassFish 5 will be the reference implementation of Java EE8. And a number of JSR submissions are finalized, and many expert groups are now in full swing. There's a small number of JSRs that are not yet launched. GlassFish 4.1 has been released. And WebLogic already supports Java E7. And by the last part of 2016, we hope to finish the proposed final drafts as well as the final drafts. And the first part of Java 2007 should bring a final release of GlassFish 5 and Java E8. So there's still time to contribute. And one way of contributing is the adopted JSR for Java E8. And this is for Java user groups. And as you see, the Ukrainian user group is represented here. And this is, adopted JSR was reasonably successful for Java E7, and we hope that it's going to be even more successful for Java E8. apart from participating in Adopted GSR, is also you can, of course, join the expert group or just listen to the expert group's mailing list. Everything is public. Most of them have repos on GitHub, so you can fork it, play around with it, and send pull requests and contribute that way as well. Or just send questions to the mailing list. So this is not complete. It's evolving every day, this table. So these are some of the user groups that has adopted JSRs. So where do you find more? Well, Java.net has project pages for all the specifications. You can go to jcp.org to find more information. GlassFish.org has the reference implementation, where you can download nightly builds of GlassFish, so you can try out the different specifications there. The aquarium is blogs that are Java EE related. So that was what I had today. I thank you so much for listening. It's been a pleasure being here. And don't forget my talk on microservices with Java EE tomorrow afternoon. There I'll demo some of these technologies, and there will certainly be more code demo and some live coding as well, and not only slides as today. That presentation will also show how to implement a service register for microservices using CDI, for example, and WebSockets and MVC. So I recommend to go to that session. That was what I had. Thank you. I think we have 3 minutes for questions. Otherwise, I'll be around for the rest of the conference.